In 8.6, we're solving logarithmic equations. So we're going to see two different types of equations, so you really need to pay attention to the difference between the two. So in the first type of equation that we'll see, it'll be when you only have a log on one side of your equation. So if we look at this, we have log of 5x equals 2. We only have log on our left side. So our first steps are to condense and isolate if necessary. So condensing, there's nothing I can condense on the left. We already have a single log, and that log is already isolated. So from there, we'll write it in exponential form. So remember, if you just have log, your base is 10 squared equals 5x. Now from here, we can solve for x. We have 10 squared, which is 100, equals 5x. And then when we continue solving, divide by 5. 100 divided by 5 is 20, equals x. Now we do need to check for extraneous solutions, and I have checked for negative because we want to make sure when we plug that in, so log of 5 times 20 equals 2, that you cannot take the log of a negative. So in this case, 5 times 20 is 100 equals 2. 100 is not negative, so we can take the log of that. If I were to, so 100 is not negative, so we can take the log of that. If I were to check that in my Desmos calculator, log of 100 is in fact 2. So check, we know our answer is correct. Great. So when we look at this, now we're seeing multiple logs, but they're still on that left side only. So because of that, we can use our log properties to condense. So I'm adding, so the log property there would be multiply log base 2. We're taking x times x minus 3 equals 2. So I still need to work on condensing that a little bit. I can distribute that x. So we're taking the log base 2 of x squared minus 3x equals 2. Now that we have that condensed, we can write it in exponential form. So 2 squared equals x squared minus 3x. Now we can solve for x. 2 squared is 4 equals x squared minus 3x. And I can subtract that 4. 0 equals x squared minus 3x minus 4. And this factors to x minus 4 and x plus 1. So x is going to equal positive 4 and negative 1, but we need to check both of those to make sure they're not negative when we plug them into those logs. So log base 2, I'm going to check the positive 4 first, of 4 plus log base 2 of 4 minus 3 equals 2. So log base 2 of 4 plus log base 2 of 1 equals 2. Neither of those have me taking the log of a negative, so we are check good on x equals 4. We could plug those into our calculator to further make sure they equal 2, but log base 2 of negative 1 plus log base 2 of negative 1 minus 3 equals 2. So here, we would be taking, so when I say here, sorry, here, we would be taking the log of a negative, and we can't do that. So that's going to tell us that x equals 4 and x doesn't equal negative 1. It's extraneous. And once again, that's because we can't take the log of a negative number. So that's what that check for negative means. Right. Once again, we only have a log on one side, so we need to condense and or isolate if possible. So in this case, we have a single log. It's already condensed, but we want to isolate that log. So I could subtract 14. So 3 log of x equals 18 minus 14 is 4. I'm going to divide by 3 so we can isolate that log of x equals 4/3. And now we can write in exponential form. Remember, if you have just log, that is a base 10 to the 4/3 power equals x. So 10 to the 4/3 power, if I were to take that, let's do 3 decimal places, 21.544 is approximately 21.544. And don't forget, we would plug that x back in to check and make sure it's not going to be negative and give us an extraneous answer. Right, now this problem's a little different because we see logs on both sides. So if we have logs on both sides, we're still going to condense, but once we've condensed, so in this case, we have log of x plus 15, can't condense that, and log of 19, we can't condense that. So since these have the same base, we can drop the logs. What I mean by that is just look at it as x plus 15 equals 19. From here, solve for x, subtract 15, x equals 4. And then once again, we want to check and make sure that when we plug that back in, we're not taking the log of a negative number. So I'll check this one. Log of 4 plus 15 equals log of 19. Now 4 plus 15 would give us 19. That's not a negative, so x does equal 4. So here's an example where we have to condense first. So using those those log properties, we're subtracting, which means we will condense this to log base 5 of x over 7 equals log base 5 of 3/7. Now that we have the same base and those are condensed, we can drop those logs. So x over 7 equals 3/7, and we can solve for x. In a problem like this, we could cross multiply. So 7x equals 21, divide by 7, x equals 3. And if I check that, log base 5 of 3/7 equals log base 5 of 3/7. Well, 3/7 is not a negative number, so our solution is 3. Here is another example where we need to condense. So in this one, on the left side, we can use our power property to move that 2 as an exponent. So log base 3 of y squared equals, on this right side, we can use our product property. So we have log base 3 of 4 times y plus 8. Do a little distributing. Log base 3 of y squared equals log base 3 of 4y plus 32. And now we have the same bases, base 3. We can drop those logs. Y squared equals 4y plus 32. Solve for x. In this case, we're solving for y. I'm going to subtract my 4y and my 32 on both sides so that we get y squared minus 4y minus 32 equals 0. And now we can factor this to y minus 8 and y plus 4 equals 0. So y is going to equal positive 8 and negative 4. But we want to plug those back in to check. So I'm going to check positive 8 first. So 2 log base 3 of 8 equals log base 3 of 4 plus log base 3 of 8 plus 8. In this case, we are not taking the log of any negatives because 8 plus 8 is 16. So we are good, and y does equal 8. Now if I check x equals y equals negative 4, we would have 2 log base 3 of negative 4 equals log base 3 of 4 plus log base 3 of negative 4 plus 8. So now we want to make sure we're not taking the log of any negatives, and when we look here, we're taking the log of negative 4. So that means, yes, y equals 8, but y can't equal -4. It's extraneous. So that is how to solve logs with a log on one side or a log on both sides.